Hi, welcome to Baby Adventure. In this video, we will look into the multiple connections of aux lights and the best possible way to. Here is a simple connection of light. A light has two wires. One wire is connected to the positive of the battery and one wire connected to the negative of the battery. The state of this connection is always on, so we need to add a switch to control the state to on or off. So we add a switch here to control the state of the light. So a switch should be added to the wire that is connected to the positive. So to control the current flow, we add a switch to the wire that connects to the positive of the battery. So when we add a switch, we added the controllability to the system, but there is no fuse protection like which protects a short circuit or overload current. So a fuse should always be added near to the battery, closer to the battery. Thus, if anything a short circuit happens, the fuse blows and protects the switch and lights. So here is another more problem coming here. High current load. Here our switch is a low current switch. If we want a high current switch, that switch becomes so physically big that we cannot accommodate here. So we use a relay here. Understanding the working of relay. Here is the light and here is the battery. And these are people who carry the high current, number 30, and these people carry high current, let us say, and from 87 we give current to the load. And here is the problem. There is a trap kind of thing, ladder kind of thing, which only activates with the low current. So if we add current between 86 and 85 of relay, the circuit closes and high current flows from 30 to 87. So one of the wire of the light is connected to ground. So again, the pins that face each other are trigger pins, and 87 is output and 30 is the input of the relay. So we place this circuit completely switch and fuse to the 86 and the between the positive and 86. So that is how you connect the relay to the circuit. High current protection yes, control yes, and short circuit protection yes. But if you observe here clearly, high current and overload happens at the 30th pin, but low current happens at the switch 86 and but. So when you press the switch, the current passes like that and glows the light. So fuse is connected to the battery or auxiliary port or ignition. But here is the catch. High current is passing through the 30 pin and battery, so we add a inline fuse to in between them. So it protects the entire circuit and lights. So another example here to get a clear view, clear understanding. Please stay focused, do not get confused here. So one wire of the light is grounded and 86 is connected to switch and switch is connected to fuse. We have so many options here. Option 1, fuse can be connected to positive, fuse can be connected to the auxiliary port, ignition, etc. So 85 is connected to the negative of the battery, 30 is high current, so it is connected to directly positive. And switch, when you switch it on, high current is passed from the battery, triggering the 85-86 contact. So high current protection done, overload protection done, control we have. But if you understand again high current, we need fuse. So we will replace it again here. So when we press the switch, high current is passed from positive to 30, and when we trigger the switch, it goes to 87 and ignites the light. So for high current, we place the fuse in line positive and high current 30 pin. Finally, one more time, don't get confused with my words, just do it practically, apply it practically. 87, 85, 86, 30. 30 is the input high current, 87 is the output high current, 86 is the low current which activated by the switch. That switch can be connected to the battery, auxiliary port or ignition. If you connect it to the battery, it is always on. If you connect to the auxiliary port, only when engine on. If it is connected to the ignition, it turns on only when ignition is on. Don't get confused, apply it practically.